I'll try not to stand there because I'm only this high, so you can't see anything. And I want to tell you what a pleasure it is to be here, not merely for the really important focus of what we're talking about today, but I want to tell you that the people in this room have been inspirations for decades. And so much, I know there's a lot to be done, but so much of the work that's been done in our community has been done by all of you. And so it's a thrill to get to be with you, to stand before you, and you know, on the bottom from the bottom of my heart and on behalf of, I'm sure, so many in the community, I want to thank you for all you've done. It's really a big deal, and thanks very much. Okay, so let's get started. And I thought, you know, what I might bring to this meeting today is sort of the perspective of the user. You know, that's been my whole career as sort of a researcher, and even when I've been in leadership positions, it's the user community that I really represented. So I thought it might be fun to sort of look at metrics of success for repositories and the issues around repositories from a user perspective. And let me start with a slide that's way too simple, but it's good to frame it. Why do we care about repositories in the first place? And from a user perspective, what we really care about is the purple stuff. So we care about innovation. Innovation drives what we do. That's what we're rewarded for. That's why we became researchers in the first place. And in the 21st century, data drives innovation in so many areas. You know, whether you're thinking about astronomy or space or biology or the spread of the Zika virus or, you know, whatever area you're in, these are data-driven areas. And our data needs a home. Data that is not stored somewhere, taken care of, may cease to exist. And so repositories really provide an incredibly important home for our data, services for our users, and really are the foundation on which this innovation goes. So, you know, how might we think about all of that? And from a user's perspective, you can think of repositories as having a really high goal. And that goal is, you know, to the first approximation that data of value is available for access and use now and in the future. That's roughly what you would like to see. And so today I thought I would sort of focus on three of these areas. What do we mean by data of value? What do we mean by access and use? What kind of services are useful to communities? And what do we mean by now and in the future? So stewardship and preservation, and how does that matter? So let's start with data of value. Obviously, one of the most important pieces of data of value is digital images of space and all around the blue planet. Okay, so what data is of value? And really the right question when you think about what data is of value is to whom? So as a society, we very much care about historical records. We care about records that we need to keep by legislation. We care about sort of cultural assets like the Shoah collection of Holocaust survivor testimony that you cannot reproduce if you lost that data. Now we're collecting tweets and emails and all of this kind of stuff. So that's really important to us as a society, and you can say, arguably, that's in the sort of public good. To me, there's a lot of data that's really important to me. You know, my tax records, you know, pictures of my kids' graduations, those are some of my kids in those pictures, et cetera. Unless my kids become really famous or in the public eye, no one is going to be interested in keeping those pictures, but I'm very interested in keeping those pictures. And so in some sense, you know, I take care of that. That's my responsibility. As a society, we try to take care of the things that are important to us. The research community is when we start getting into trouble. So what's important to the research community? And if you think about value, and these are types of values that researchers told us in the Stewardship Gap project that Myron Gutman and Jeremy York and myself and a number of advisors, including Tricia, who's here, were thinking about is, you know, what is of value to researchers? And it turns out that, you know, a number of different things, not just one thing. So data is valuable to you for your own research. Data is valuable to you if it's in a highly cited publication. Data is valuable if your funding agency is making you provide it to the public. Data is valuable for you that if it underlies assessment reports. And so there's a variety of reasons that data might be valuable to you, and you might want somebody to help you with the stewardship and preservation of that data. Now, if we look around, value is really in the eye of the beholder. There are reference collections like Arabidopsis collection that Ava is doing it, and PDB that Helen was involved in, a number of people are involved in. There are irreplaceable collections. Those are really valuable to us. And then this is just sort of the tip of the iceberg, a number of groups from the Research Data Alliance, all who have valuable data in various ways and are storing them and using them in various ways as well. And you see there's just a wide spectrum of groups from, rice data to on-farm data to health data to linguistics data to marine data to small unmanned aircraft systems data, et cetera. All of those are, translate into collections and data sets that are really important for the research of individuals, projects, communities, et cetera. So your mileage is varied, but all of these are considered valuable. Now, one of the things that in the Stewardship Gap project, what we did was we asked about, roughly under 50 respondents, 46 respondents. They had about 120 data sets from nearly 80 domain areas. They were mostly NSF and NIH data sets with some data sets from NASA and NEH and Sloan and the Bureau of Reclamation, et cetera. And we did a rather in-depth survey of them to try to understand the relationship between their interaction with the data and their stewardship choices. And I'll show you some more graphs later on as they're useful in the talk. But there was a number of reasons they gave us. This was not things we gave them, but they gave us for why the data was valuable, including use by others in their own research and difficult to recreate. They had to store it by mandate or audit, et cetera. And the colors here correspond to how long they thought the data was valuable. So blue is indefinite. A lot of people thought their data was going to be indefinitely valuable, forever. A lot of people thought it was, greater than 10 years or less than 10 years, et cetera. But one of the things that should tell you is that, forever is a hard word. It's a hard word to fund. It's a hard word to justify. But a lot of researchers really have a more sophisticated sense of the timeliness of their data. And as time goes on, these things change. So this graph will evolve, 5 years from now, et cetera. Now, one question you might ask, which is really the key question if you're looking at it from an organizational perspective, is what value of data is worth what amount of stewardship? And, in that sense, we're trying to trade off what we need the data for, how much we're going to invest, and how long we're going to invest it. And so that's a really key question. It's a question that every organization that tries to host or steward data has to deal with. And typically our discussions in the community of value and investment are largely decoupled. So oftentimes we talk about stewardship of data, we talk about support of data, but we're not coupling it with this notion of valuable. It's like everything's valuable or nothing's valuable, it's valuable forever, it's valuable, not forever. And the fact is there's a lot of sophistication in those terms, and it gives us something to grab onto as we start thinking about, well, what can we actually do about it? One sort of simple way of thinking about it is, and I apologize if this looks like it's small font, so those of you at the end of the table, so just ask me what these things are, is that you start with the data collection and imagine that we have some community value criteria that tells us where it's going to go. And where it's going to go means, is somebody else going to take care of it, or am I going to take care of it? And so does it meet those criteria or not? And then sort of over time, because you might want to periodically reassess things. Has it gotten more popular? Has it gotten less popular? Is it more valuable to the community in some way, shape, or form? Then you want to reassess it and maybe change where it gets hosted or where it gets stewarded. So, in some sense, if we knew what the criteria was for where it goes and what the bar was, how high, does it have to be, and how low does it have to be in this various boxes, and what these time periods are. It might give us a way towards economic models that were more manageable than forever or not forever, completely valuable or not valuable at all, right? So we have to sort of get our heads around it to be able to do something that's actually actionable. So, what metrics are of value to users? So, and user communities. And you can think about, there are sort of the popularity metrics, and that's, data that's associated with highly cited publications and data that might be, downloaded a lot of times, or they have a lot of hits, or they have a lot of distinct users, or they have a lot of return users, etc. You could think about things that are sort of our responsibility. And that's data that's expected to be retained by somebody. For example, maybe your funder expects you to retain it. Data that might be unique or hard to replace and that is of community value. Data that you're storing as a dark archive for somebody else. And then you can kind of think of some reasons we want to store data because it empowers us. So data associated with prizes and awards in our community, science breakthroughs of the year, things like that, we need to keep that data. That's really important to our community. Community reference collections are really important to keep. And this is a bit hard to quantify, but if we could, it would sort of give us a little bit of a way of moving forward. So what's the data on which it's likely that new results will depend? And if we can kind of start figuring out what that is, we can get away from these extremes to start building models that help us host the data in this gray area. Okay, so let's move to the next thing, which is access and use. And data, we have data value, and we have to figure out what we mean by value and how that relates to stewardship and how that relates to investment. Now let's figure out sort of what access and use should mean to us. And first of all, to a user, access means, where's the data? And does the data I need exist? And in some sense, if I go to ICPSR or, I go to, a repository, I'm going to be able to sort of look through the data and sort of find out what's there. But what if I want to go up a level? And what if I want to ask the question, does this data even exist? Where would I go to find it? And it turns out that that's a hard question. And we've looked at it as a community in a bunch of different ways. One way we've looked at it is to say, well, can we, make some sort of like a whole Earth catalog of, all the data that's out there and all the repositories that are out there. But the problem with that is, as soon as you even get that stuff on a website, it's out of date. And so the refresh problem is really hard. You could also say, well, let's do it like we do everything else in, modern life. Let's see if we can Google it or Bing it or, Internet Explorer it or DuckDuckGo it or, pick your favorite browser. But the problem is that for the scientific community, the data associated with publications and data collections, not a set of keywords that typically my browser has. So it's really hard to use that unless there's something that is done to collections and to browsers that help me do it. Then there's the keyword problem itself. So when I ran the San Diego Supercomputer Center, I was, you could have called me a parallel computing guy or a high-performance computing guy or a parallel processing guy or a grid computing guy. And if you looked at any one of those terms, you might miss some paper, some reference, or something where I was identified in the other, with the other terms. So, and this is sort of the tiniest tip of a huge iceberg for a lot of the things that we do. We have terms, we don't have really mainstream consistent terms that absolutely almost everybody uses. A lot of times we make up our own terms. And so how do we sort of find stuff when we want to find stuff? And then, lastly, we have the problem of timelines. If I'm searching using a regular search engine for a particular data set that I saw in a publication, how do I know which version of the data set it is? And one thing that one of the groups in the Research Data Alliance has is a really nice way of kind of putting a timestamp on data sets. So the Dynamic Data Citation Group is able to use a bunch of guidelines to say how you refer to the data set, et cetera, so that if I read the paper and I want to reproduce the results, I'm reproducing it with the same data set they used and not the updated version of it. So, so some of those problems, you can kind of solve, but some of them are technical problems that need to be solved in order to use what we think of as sort of normal searching techniques. So access turns out to be, both sort of a social problem, but also a technical problem that we need to solve. Also, the next thing to think about is access is not good enough. So, I may know that, pile O data is somewhere, but, I actually want to do things with that data. And as a researcher, that data isn't useful to me if I don't know what it means, if I can't find it, if it's not in the right form for analysis, if it's not preserved in a way that I can reproduce the results. So all of that turns out to be really important usage tools and services that I would like to have associated with my data. Now, so this talk will be available, and I know you can't read it, but let me just tell you, let me encourage you to read this slide at some point, and let me tell you what this slide is about. So, so recently, through a set of situations, we've been talking with the Internet Archive, who's very interested in doing hosting of data. And they think of themselves as scientific data, not just, web crawls. And they think of themselves as the big hard drive. We'll be the big hard drive. We'll be there for free. We'll be there forever. And so what we did is I asked some of, not a statistically appropriate sample, I asked some of the RDA groups that I thought might need some stewardship. Would this be of interest to you? Would you be interested in putting your stuff in the Internet Archive? I asked 4 people. Of one of them, they said yes. We'll definitely do that. The other 3 had caveats. We're only interested if, there's some persistent identifier, or there's a service level agreement, or, there's some sort of services that help me use this frequently. And by the way, they have to promise sort of not to go out of business soon and dump my data back to me like happened in my home country of X, right? So users don't just want a big hard drive, they want to make that data useful for themselves. And so that's a really important thing for repositories to think about, what are its typical cohorts, what do they want from their data? And how easy will it be for them to kind of create these use case scenarios? So, what are sort of general things? Just in this room a few months ago, the SCIES advisor for the SCIES Advisory Committee meeting, SCIES had a data science subcommittee looking at data science and what SCIES could do over the next decade. One of the images from the report from that group was sort of a cartoon about the data life cycle or a data life cycle. Everywhere along here there are services that users want. There are services that take the data from instruments and fieldwork and surveys and devices and put it in some reasonable form for use. You need to organize it or filter it or clean it or, attach metadata to it, whatever. You want to use it in various ways. Maybe you want to analyze it or mine it or visualize from it or, or compute with it or do a lot of other things. You want to publish it. Maybe it's there available for the community on a portal. Maybe it's you create a database that people can use. You couple it with literature. There's all kinds of things you want to do. And of course, what you want to do is, as you go along, make sure that the appropriate policy is relevant. We're taking care of it for stewardship and preservation. There's a record of its provenance, et cetera. So, all of these things involve services that users want around their data. And it's really important for us to think about how do we make that easy, because at the end of the day, the goal for a researcher is for the innovation to be the roadblock, not for the technology to be the roadblock. Technology should be the enabler. And, just the challenge of solving a problem that's never been solved before should be the roadblock. Okay. So many service models are specific to communities, and I grabbed this off Maggie's and and the PDB website. You know, these are things that are advertised. They're really useful for those communities, and my assumption is that communities have gotten together and talked about what's useful for them, and there's been a good dialogue. One of the RDA groups that I think has been doing such cool stuff is the Wheat Data Interoperability Working Group. If I want to answer the question, you know, what kind of strain of wheat is going to thrive right here, you know, I might want to look at the air quality and the rainfall and the germplasm of the wheat, you know, to sort of figure out what's going on. And to be able to even interoperate among those data sets, I need a common vocabulary. So they're doing, you know, simple infrastructure-y kind of things, which is how do we develop a common vocabulary? What are sort of data formats and standards that we might want to look like? What's a prototype interoperability framework for questions like the one I just asked, et cetera? So, you know, what the kind of services they're looking at are kind of how do I look at standards? So let's talk about standards for a second. So we all love standardization because standardization really simplifies things for communities, and whether you're looking at, you know, the astronomical visualization metadata standard, which sort of helps people from the astronomy and astrophysics community, to the Oscars.org. You all probably saw that very interesting show, especially last few minutes. One of the things that the science and technology part of the Oscars are doing are really trying to figure out, if I make a film and the colors need to be the same, whichever device I'm showing it on. And they actually have some standards that they're looking at to make sure that the colors are going to come out to be the same, whether it's on my iPhone or my laptop or whatever. So standards are great, and they really help us understand things. But standards before the right time are really bad, because what we need to do is experiment with what's useful. And so here's another thing that professional societies and repositories and communities can get together, is to try to figure out, when is that tipping point? When we've had enough experience with various ways of approaching things that we can settle on something that's going to be pretty reliable and pretty good most of the time, and that's our standard. And that actually takes some thought and some evolution of the community. And then, you know, another question to ask is, you know, what role should all of us play in that process? Should it be, you know, should funders and publishers and professional societies and domain communities, the Research Data Alliance and other kinds of groups, you know, what is the appropriate role for all of them? And so those are things we need to be thinking about as well. You know, it isn't a Fran talk unless I have, you know, things cost money. We have to pay, and all these services cost. So at SCSC back in the thousands, Helen might remember this, we put together a repository called Data Central. Natasha Bollock ran it, and what we wanted to do was provide a place with services and hosting for community data sets of any type. So we had about 100 data sets, and they went from, you know, art collections to seamount collections to, you know, chemistry collections to astronomy collections. And we did it for free, nice for us. We eventually went out of business doing this for free. I mean, at least out of business with respect to this, because the cost of services and storage are prohibitive. And especially, you know, as you're responsible and you make several copies of each data set, and we had several petabytes worth, you know, at some point you just can't absorb it. You need a viable business model. And then what we tried to do is provide a lot of extra stuff associated with, so you could create a portal, or we would help you with data analysis and mining, or schema design, or consulting or training or other kinds of things. So it was a valiant effort for us. I'm really proud of it, but ultimately the economics will come to bite you, and I think all of you know that really, really well. So, you know, when I start thinking about measures of access and use, you know, what success look like, if you go to, you know, PLOS Biology and some of the PLOS publications, you know, you kind of see the Yelpization, I don't know if that's even a word, of it, where, you know, I can share it or comment on it or write on it. This is a paper that Phil Bourne and I wrote on gender diversity in data science a while ago, and, you know, are our scores good or bad, you know, and you can decide for yourself. But The fact that I can kind of look at that like I look at, the new sushi restaurant in Troy, New York is a pretty interesting and new thing for our community. And so one way this sort of provides us one way of getting at some metrics that we hadn't gotten before, but they're generally popularity metrics. And I think we would all say that, much data, some data is still valuable even if no one ever downloads it, or if people don't download it now, but they may find it valuable later. So stewardship and preservation shouldn't just be about popularity, and we have to find a way of thinking about it. And, at the end of the day, organizations that provide hosting of data really need to figure out, how you allocate the real estate of your budget, right? How much of it needs to be put into, sort of organizational stuff, and how much of it needs to be in the stewardship and preservation activity, and how much of it should be in services. And what are you going to get return on investment for? And those are hard decisions to make, and they're often custom and individual decisions. But they're worth thinking about because they get us beyond the yes or no, forever or not, valuable or not. They get us into the area where we actually live. Okay, so let me talk just briefly about best practices for data repository, stewardship, and foundation. My favorite, data gone wrong pictures that I'm sure you'll recognize. And first of all, let us say that stewardship and preservation challenges are real. A lot of the data, is not stewarded well, gets lost. I think that a lot of good efforts in the private sector, we can't assume that they're going to take care of the whole problem. They're not. No one sector is going to take care of this whole problem. And so, it's really important for us to come up with sort of multi-sector, diverse solutions that really help us provide the stewardship that we need. So what are the best practices for data stewardship? And from an organizational perspective, there have been a lot of, in some sense, rubrics and ways of thinking about, do I run a good repository, right? And so you can see, are you track certified, and are things reasonable with respect to community best practices? From users' point of view, they're thinking about different things. So they want to know that you don't lose much data, and you definitely don't lose their data. Do not lose my data. You can lose other people's data, enough so I can respect you in the morning, but don't lose mine. They want to know that you're reliable, that you're sustainable, that you're going to be there. They want to know that things are easy and that there are services if they need them. They want to know that they can link data to their publications, because that's what researchers are rewarded for. And they want to know that the repository is respected by its peers, and so since you don't want to give it to a place that the community is not going to respect. One of the things that Myron and Jeremy and I wanted to look at is, can we tease apart the various ways that repositories can satisfy users and get better? What does that gap look like? Is it all just a money issue? Is it just like, we dump in a lot more money and problem solved? And so we asked in these in-depth interviews that Jeremy did, we asked users, and what we wanted to try to understand is this space between well-stewarded data and data at risk. What are the gaps there? And it turns out that there's a bunch of different gaps, but there's sort of three different buckets of gaps. One bucket is probably what you would expect, is that people don't have enough resources. And that resource might be money, it might be insufficient tools, technical issues, might be insufficient facilities or staff, et cetera. So those are sort of resources that you wish you had, but you don't. One bucket is really sort of what you can think of as cultural and social gaps. So there's an intention of stewardship, but there's no commitment, right? There are differing expectations between researchers and funders and repositories. There are gaps between, what happens at France repository and good practice, right? So there are, cultural distinctions. And then there are political gaps, and those are sort of, there's no wind in the sails. There are no stakeholders sort of willing to stand up and say this is a real problem, and it's important for us to cover those other social and resource gaps. And so the political problems are often, quite important. Now, this sort of explains a little bit about what, our 46 respondents with 120 data sets thought. And the interesting thing is, you think about this value, right? 40% says their data is of indefinite value, but only 6% of those the respondents had a commitment, right? So you think, there's a disconnect there between, what the commitment is and what we think the value is, sort of back to that. And back when I was involved, as some of you were, with the Blue Ribbon Task Force for Sustainable Digital Preservation and Access, one of the things to recognize is there is a bunch of players in the digital world. There's people who make the data and who benefit from the data and who select it and own it or have rights to it and preserve the data and pay for it. In the private sector, those groups are largely the same. If I'm Google, I collect the clicks, I prize the clicks give me competitive advantage, I store the clicks, I use the clicks, I pay for the clicks. I'm good with that. If I'm in academia, those are often really different groups. The folks in the field generate the data and everybody benefits from it, and the folks who generate the data often select the data. Maybe the university has the rights to the data. Sometimes it's a little hard to figure out. Maybe a third party preserves the data. Maybe somebody else entirely pays for the data. And when those groups are not together, oftentimes you have this kind of stakeholder problem. The last thing I guess I want to say in sort of this section is, okay, so we all know it's a problem. You all know this more than anyone in like the universe, right? And so why, and you guys are, smart and you're out there beating the bushes all the time. How come nothing is happening? And my own sense of that is, this stuff is hard to sell. Plumbing is hard to sell. This is sort of the plumbing of the data world. And, there's not, you don't have newsworthiness when the water runs in the sinks and the bathrooms, and I get services that serve it up to me the way I need it. No one thinks about that or remarks on that until something breaks. So oftentimes, providing good infrastructure to support data, it's just not newsworthy. Now, on the other hand, supercomputers, we've got it good there because somebody gives me a bunch of money. I run I have a supercomputer. It's on the top of the top 500 list. I do some breakthrough calculation. Everybody's happy about it. Never mind the fact it doesn't have to run consistently every single day. It can be down. I can get a different slot of money for a different supercomputer, and there doesn't need to be continuity. So, some kinds of infrastructure kind of fit in our newsworthiness and opportunity costs, and some do not, and data typically does not. Oddly enough, this is a really good time for data preservation. And data preservation has been a lot in the news with the change of administration. And there are a lot of people in the scientific community and elsewhere who are spending a lot of time thinking about preservation. How many archiving and preservation articles have you seen in the New York Times and the Washington Post and other Science Magazine, other kinds of publications? I think something that will be interesting for us is, okay, so data we thought might go away is now being preserved, but where's it going? And, how are we going to find it now? And, who's going to sustain it? And so I think, this is sort of the first step in kind of an evolutionary process with respect to that data. But, in some sense, maybe the next question is, what are our responsibilities around that? What can we do for our community so that data will be there? Okay, so I guess I want to get back to the original question. And, so what repository metrics speak to usage and users? And, kind of 4 buckets of them. There's a bunch of stuff we can do to measure, you know, the number of collections or the users or return users or web hits or whatever, users and usage. Empowerment, which is, you know, these are really collections that bring about really interesting and important new ideas. And so, you know, what do we need to keep around that's going to be of value for doing that? We need to be responsible for keeping things, reference collections or unique or hard to place collections. And then we need, you know, I think with respect to repositories and the organizations that are stewards for our data, we have to have adequate, what I think of as the ilities, reliability, predictability, sustainability, affordability, accountability. You know, all of those things are characteristics that it's good for our repositories to have. So, you know, last but not least, you know, okay, so here's my goal. Data value is available for access and use now and in the future, and if I sort of level up and think about the ecosystem in which this lives, how does that ecosystem really, you know, how do I create a healthy ecosystem in which to support these things? And I would offer to you that I think a healthy ecosystem has three characteristics. First of all, I think it has stakeholder biodiversity. I think if we expect the government or Google or, you know, Elsevier or, you know, anyone else to keep all the data, you know, we're not going to survive. I think it's got to be a shared responsibility, and I think the more we can kind of coordinate and make sure that we have the appropriate kinds of partnerships, the better. Second of all, I think that we have got to come to terms that the provision of infrastructure to host our valuable data is not research. I mean, there's research involved in making these technologies better and all of that. It is infrastructure. When I, you know, drive my car, I am not worried about whether my asphalt is innovative. I am worried about whether my asphalt has potholes. I am worried about whether the road is smooth. I'm worried about whether I can get from point A to point B. That's how my road is measured. This infrastructure should be measured on its usefulness to the community, and that means that we might need a longer time frame and a different way of measuring it and a different way of supporting it. And I think we've just got to get realistic about that. You know, I don't think about my light company as doing novel new things. I just want lights in my house. So, and then the last thing I think we have to start thinking about, which we're already thinking about, is culture change. And these are not just technical problems. They're social problems as well. They're political problems. They're community problems. And I think it's really important for us to sort of think of those more holistically. And I think that really will help us get to where we want to go, which is data of value is available for access and use now and in the future. And with that, I thank you.